Howdy, welcome back. This is part 2 of the two-part series on making a hammerhead on the little road shaper. So let's get started. Now in review, if you have not watched part 1, again I'm making a hammerhead out of 3/4 inch square stock, mild steel. This cannot be heat treated, 5 inches long, and this is a sample that I made up just so you can see what it looks like. And in part 1, I had done the layout. Actually, the layout will be shown at the end of this part. But looking at the layout here, you can see that I have made the bevels here on all 4 corners. And now I'm ready to put the angles on, like this on the sample. Now, how am I going to hold that? Now, again, there's always more than one way to do it, but here is the way that I'm going to do it, and that is to set the work at an angle like that. And I'm going to lay a little bit of a straight edge there so that I can get that layout line a little bit above the vise jaws. We do not want to strike the vise with the tool. I have a set of taper blocks like this, and this is 10 degree, and at the beginning I thought possibly I could use that to hold the work at an angle, but this is not 10 degree. I don't know what it is, I didn't really measure it, but 10 degree would be at that angle, and that is not the correct angle. There is no 9 degree block, so and there certainly is no 9.5, so I'm not going to use angle blocks, but that is a possibility for some projects and some setups. You can see that's 10 degrees. Forget that. So here's the way we will do it. Again, that is a little parallel there. It's a piece of key stock is what it is. And I want to get that line right on the edge, and I will get down very close with a good light and a magnifying glass so I get it right on, and then that can be taken off and the shaping can begin. You probably can't see it, but there is a line scribed right there which is the termination of the taper, and that will take several passes. Now, a fella could bandsaw some of that material off and speed things up, but then again, this is a shaper project. And it can be tapped into submission until the layout line is perfectly parallel with that straight edge, and then tighten the vise. Now, I don't care what kind of machining you're doing, we need rigidity. So notice that there's a minimum amount of tool holder sticking out of the tool post. The tool itself is really choked up, so there's not much sticking out there. There's not a whole lot of work sticking above the vise, and then I will raise the table, whoops, I went the wrong way, until the tool is very close to the work. Also, if you can look here on the tool slide, there isn't any hangover here. You don't want a lot of hangover and unsupported part of that dovetail that can cause vibration, because this machine is a light duty machine and we got to give it all the help we can. And here's a little bit of irrelevant, worthless information. I see in the background there's my shop vac, and I read just the other day that the shop vac company closed its door in Pennsylvania and laid off permanently 400 or 500 workers. So that's the end of shop vac, which has been around for about 70 years. And also, since this is a relatively simple cut, just straight across, I have the machine head here, the cutting head, perfectly vertical at 0 degrees, and the clapper box, you know, can be tilted one way or the other, and it doesn't need to be tilted for this purpose. And as always, before I turn the motor on, I am turning the hand wheel to make sure that the cutter in this ram is in the correct position and that there is no interference, and I will not crash the machine. Do that every time. Don't take the chance. And as I told you before, I'm going to touch off here until I have a little scratch. You see it hit? And now I will feed down 25 thousandths and take my first pass, and let's see what it looks like. One full revolution is 100 thousandths, so I'm arbitrarily taking a 25 thousandth depth of cut, which seems to be within the capacity of this machine. And I'm using the power feed. Feeding about 4 or 5 thousandths per stroke. You cannot hear the clapper box clapping, nor can you see that it's clapping, but it is ever so lightly, and that's why I had my thumb here. Not a good idea to put your hand on here, but I had my thumb here, and I could feel it moving ever so slightly out on the return stroke, and that's the purpose of the clapper box, of course, is it not? So there is no cutting or wearing of the tool on the return stroke. Now, I certainly won't be showing all of this, and some of it will be sped up because it's greatly repetitious, but interesting for some of you to see. So I'll just take this pass, and then I will show you the final pass. And on the final pass, my depth of cut will be less because these are roughing cuts, and I would like to use a finishing cut, so maybe just a depth of cut of perhaps 5 thousandths on the very last pass across the work. And this is the final pass. Okay, that's it for that side, and that took over 30 minutes. So it is not a fast process by any means, but my surface finish is pretty decent, I think, for a shaper. Now I'm going to go ahead off camera and set it up, flip it over for the other side. I'll just show you the setup and maybe the very last pass on this side, but other than that it's all repetitious. And there's the setup for the second side. Ready to cut. Here's the final pass with about a 10 thousandths feed, and this is 100 strokes per minute approximately. I'm not sure I told you that. That's it. Right down to the line, and the shaping is completed. It looks pretty good. Let's go on down to the other shop and do a few final operations, and then the job is done. I'm down in the basement shop now, and the last thing I need to do is to make this slot 3/4 long, 3/8 wide, but I just laid out a couple holes, and I'm going to drill 2 holes. Just makes it easier to do the slotting. I won't show that. I'll meet you over at the Bridgeport mill presently. I have already touched off and found the center line of the work. The hammer handle slot looks pretty good. Now I've got the miter gauge set for 45 degrees. I'm just going to chamfer those 4 corners ever so lightly. The face of the hammer was sanded some time ago using the miter gauge, so it's nice and square. That could have been done on the shaper, but I think it would be overkill. Now I'd like to put a little bit of a radius on the peen end, just by swinging it like that. As I told you, when this was hardened in the shop, we did surface grind it. Now I could take the bluing off with thinner. I could have sanded this on the belt sander when I was over there. You could draw file it. You can do anything you want. You can do nothing. But this is 220 grit paper on the surface plate. Let's see what that looks like. And I'll finish that by hand. You don't need to see that. I'm not going to put the handle on, and actually this is a useless project because it's soft steel. But I think you get the idea of how to do it. It could have been done in 5% of the time on the milling machine. This also could be sanded or polished, but I'm not going to. You can see this is a good high school project because the kids get a lot of different operations on it. On the Bridgeport mill, this could have been machined down in a matter of a minute or two, or it could have been sawed off, most of it, and then milled. And the way we handled this, again, we held it at 45 degrees and used the side of the end mill, and that gave you a nice little radius in here. Although the shaper dealt with that termination rather admirably as well. I hope you enjoyed the video and the use of the little Rhodes shaper. Be sure and watch both parts. This is Mr. Pete saying so long for now, and I'll see you next time. Alright, here's the layout. This is the end of the video. Real quickly, I like to draw center lines, so I'm just on the tabletop. For this, there's really no need to use a surface plate, but certainly use one if you want to. Next, I will lay out these bevels on all 4 corners, 1.25 inches approximately, and I'm going to go all the way around on that so I don't lose my lines as the work gets scratched. And you don't have to use a height gauge, it's just that I love a height gauge. The drawing calls for this dimension right across the peen to be 1/16. I'm going to make it 1/8. So in order to locate that, I have the height gauge set for 5/16. If I can get my hand out of the way. So I'll mark it there. Flip the work. The taper is 2 inches long. Height gauge set for 2, and I'm going to again carry those scribe lines all the way around, and you might understand why a little bit. But you could do that any way you wanted. With the straight edge, I will connect this point with this point, and the same thing on the other side, simply setting it like that and laying it out as accurately as possible. That was tricky for high school kids. The slot for the handle is to be 3/4 long, although that's not real critical. So here is the extent from one end of the other to that hole, from right here to right here. I've got that laid out. And then at some point along the line, I'm going to drill a couple holes right here and here, and then mill it out, although the holes aren't even really necessary. But I like to do that when I'm plunge cutting. That'll be much later on and is probably irrelevant to this video because it is milling rather than shaping. Well, that concludes the layout. That's all there is to it. Let's go on out to the shaper. Well, actually that's already done because this is the end of the video.